Hi everybody, today we're talking about functions, and instead of starting from the beginning, I want you to think that we're going to revisit the idea, and instead of looking at this through the lens of algebra, we're going to look at functions through the lens of discrete math. So you're probably thinking you already know about functions, and I agree, you do. But now I want to rethink about how we talk about them. I want the concentration to be on sets and on mappings. So what you already know is that functions are all about inputs and outputs, and more specifically, there's exactly one output for each of the inputs we have. You're probably used to thinking about functions with equations and maybe even graphs, but we're going to change this part a little bit. In discrete math, we want to have less focus on graphs. We want to have more focus on sets and notation. So we're thinking about the relationship and the structure behind it. To help us out, we're going to look at a definition of a function coming from a discrete math perspective. So we'll start with having sets x and y. Then a function f from x to y is a subset of the Cartesian product of x and y. In this Cartesian product, we want to say for every x in x, there's exactly one y in y, where xy is in the function f. Let's take a look at that as a mapping. When we map functions, we go from a domain to a codomain, and we'll talk about the codomain a little bit more. In the domain, we'll have our x values, and those x values will go to some y values. And I want you to see that we have arrows that we could use to connect the values in the domain over to the codomain. So let's look at that a little bit more closely. We have these three words, domain, codomain, and range. Domain and range you know from functions, but it's going to look a little different now that we're talking about discrete math. Domain is still going to be the x's, which is the set of all values you're allowed to plug into the function. The codomain is the y's. And this is set up from the beginning. When we describe our function, we say we go from one set to this other set, so maybe the reals to the reals or the integers to the integers, but I want you to see it's a set of values the function is defined to map into. So this is said before we start evaluating the function. The range is the actual outputs, so it's the set of values the function actually produces rather than the ones we state from the beginning. Let me show you that with an example. Let's say we have this function f that goes from the integers to the integers, and the function is f of x equals 2x. We could write that as the set of all x to x, where x is an element of the integers. So here we're going from our domain of the integers over to our codomain, which is also the integers. Our codomain looks like all integers. We have negatives, we have positives, we have 0. But when we look at our range, we only have even numbers like -4, -2, 0, 2, 4, and that would continue forever. You can see there's a difference between the codomain and the range. The range doesn't have any of those odd values. In reality, the range is a subset of the codomain, so the range is the values we actually hit versus the ones we're allowed to hit. Let's take a look at that with a smaller finite set. I'm going to do a function f that goes from x to x, where x is the set of numbers 0, 1, 2, 3, 4, 5. This time f is defined to be x over 2 whenever x is even, and it's x plus 1 over 2 if x is odd. Let's plug all of those values in individually. We'll start with 0. 0 is even, which says I should divide it by 2 to get 0. When we do f of 1, we're using x plus 1 over 2, since 1 is odd. So 1 plus 1 is 2, 2 over 2 is 1. When I go to the value of 2, 2 is even, so I have 2 over 2 is 1. 3 is odd, so I have 3 plus 1 over 2, which is 2. 4 is even, I divide by 2, I get 2. And lastly, 5 is odd, so 5 plus 1 is 6, 6 over 2 is 3. I have my function f, which is the set containing 0, 0, 1, 1, 2, 1, 3, 2, 4, 2, and 5, 3. Let's map that from the domain to the range. So in the domain, I have a set with 0, 1, 2, 3, 4, 5. The range only has values 0, 1, 2, and 3, so let's write those in. Now we can map each value from the domain over to each value in the range. So we know 0 goes to 0, 1 goes to 1, 2 also goes to 1, 3 goes to 2, 4 also goes to 2, and 5 goes to 3. This is a good reminder that each x gets one y, but we can repeat y's for different values of x, like 1 and 2 both share 1, 3 and 4 both share 2. So to make sure things are crystal clear, let's go through one more type of function. We're going to do f is a function from the integers to the integers, and it's defined by f of n is 2n squared plus 1. So my first question is 9 in the codomain of f? And the answer is yes. 9 is an integer, so it is by definition in the codomain of the function. So my second question is 9 in the range of f? Well, that's a little bit harder question. So what we have to do is find out if 9 satisfies 2n squared plus 1 for some integer n. We'll have to solve this equation. So I'll start by moving the 1 over. I have 2n squared equals 8, so I want to divide by 2. That says n squared is 4, so let's take the square root of both sides. When I do that, I find out that n could be either 2 or negative 2. Since 2 and negative 2 are integers, that's good news. It tells me that yes, 9 is in the range because I found values in the domain that map to this value of 9. So let's try that one more time, but let's switch our number. I'm going to look to see if 5 is in the codomain of f. Just like last time, I look at 5. 5 is an integer, so that says 5 is in the codomain. So we ask the harder question of, is 5 in the range of f? Just like last time, we're going to set 2n squared plus 1 equal to this value of 5. I'll move the 1 over to get 2n squared is 4. I'll divide by 2 to get n squared equals 2. Then I'll take the square root. And I don't even have to worry about the plus or minus when I take the square root. As long as I get this number, the square root of 2, which is not an integer, I kind of want to stop and say, no, 5 is not in the range of f because I got a value of x that is not in the domain of my function.